Hello, this is Hazel from C-Trax Customer Support. This video is an overview of the schematic part editor within the Excel Designer PCB CAD software. You may find that this overview is sufficient for you to actually go ahead and edit your own devices, but there will be another video that will go through part creation in a step-by-step fashion. So what we'll do is have a look at some of the parts in the master schematic library and talk about the features that you'll find in there. So we expand the masters folder, which you'll find up in the navigator pane, and then expand the schematic library folder. This folder is divided down into lots of subfolders, each containing a category of components. So you've got the 74100 series at the top, 741 with drawn to a different standard, the IEC standard, and then moving on down, lots of different categories of device, and I'll leave you to expand those folders and have a look through. But what we'll have a look at today are some resistors. So we'll expand the resistors folder, and in here there's lots of resistors. Now it may be that you only need a couple of resistors, and what we'll do is have a look at a few of them. So we'll look at this resistor to start with. This resistor can be used for any resistor that's got a footprint which is 1/8 of a watt package. This one is for 1/4 of a watt package, 1/2 a watt, and so on. So we tend to define the schematic parts for the footprint, and then once the resistor is placed on the schematic diagram, we change the value. So we just have one schematic part for all the 1/8 watt resistors and just change the values on the screen. That works fine unless you've got a stock control system in place, and where you would need to have one resistor for every part that's in your stock system, in which case you would have hundreds of resistors. But the way you would cope with that is to create the first one and then right click on it once it's been finished, use the copy function, and then right click over the resistors folder and use the paste function, and that will introduce a copy of that part into the library, and then you can just change the value and its name, obviously. So going back to a resistor, we'll select this one. You can see down in the browser pane there's just a little picture of it, and if we look at the properties tab, we've got a little bit more information down there as well. And it basically tells me that there's one symbol within this part. The prefix is R. It calls up a footprint called Res A8, and that's the footprint that will sit on the artwork. And the default value is 100K. If we look at the next one down, this one calls up a slightly bigger outline, but everything else is the same, and then so on. So if we just open up one of these resistors and have a look at it, the important things you need to be aware of are the symbol attributes. If we just go to the attribute symbol command, you'll get a screen come up which tells us the information about the part, and this is all being user defined. So when the part is created, you come to this window, double click on the value that you want to change, and then just type in what it is you want to see. The important things are obviously the prefix, and that's determined by what you want to call your components, R, I, C, D, C, whatever. The footprint, the outline, and this is the footprint that is used on the artwork. So if it was a dual inline 14, you'd type in the DIL 14 package name. You will have to create these footprints before you start working on your artwork, but they don't have to exist as you create the schematic part. And you may say, well, how do I know which value to put in there? If we just cancel this window and close this one down, just very quickly, if we go back up to the top of the masters folder, you've got a component outline folder there, and if we expand that, this is all the physical footprints that are supplied with the system. So 0805, there's your 0805 package, and then if we find the Res A8, again it's all alphabetical, Res A8, which is the one of the footprints you saw earlier, and then the Res A10, Res A12. So you can scroll down through the component outline folder to find what footprints you've got, and there's lots and lots of them there to choose from. And again, if there's not one there and you're making a schematic part, then just choose a name and put that in the part attribute window, and then make sure you come back and create that footprint later on, and that will be covered in another video. So we'll minimize the component outlines and back to the resistors. We were talking about the attribute, sorry. So going back here, and the default value is being assigned as 100k, and as I say, put in a value that you use most commonly, and then when you place that part on the circuit, it'll always come in with that value, and then if you need to change it, you can edit it on the circuit diagram quite easily. A few other things you can do in this window. It's telling me that the number of equivalent symbols within the part is set to 1, and I'll come back to that in a minute. We can show this symbol filled if we want to. We can choose a colour. We can choose a nice bright colour from the palette. And then if we OK that window, you'll see that the symbol is filled in with a colour. Can be useful if you've got certain parts that you want to stand out on your circuit diagram. All the attributes can be hidden or they can be made visible, and this column controls that setting, and then the height of the attribute when it's visible is controlled from this column. And again, anything you want to change, just double click on it, type in the new value, decide whether you want it visible or not, or you might want to see the attribute name and the value that's been assigned to it. Not often, but sometimes you might want to. You can also add your own attributes to schematic parts. So if you had enter the price of a component, you can maybe specify the attribute is called price, and then put in the price. An expensive resistor, but there we go. And you could choose to, for example, not have that visible because you don't tend to want to see the prices of things on the circuit. So now this resistor has got a price assigned to it. All the attributes can be extracted off the circuit diagram in any format that you like. There is another tab in this window, the part power pins, but I'll come back to that when I look at another component in a minute. So we'll OK that window. You can see we've got two terminals on this particular part, and so if we go to the attributes and look at the pin attributes and select the pin, you can see we've got the outline pin reference. That's the actual pin number, the physical pin number of this particular pin. If it's got a name, you can type in a name. Obviously resistors don't have names, so we don't worry about that value. And you can specify a logic type and choose from one of those options. And then when you use the parts on the circuit diagram, there's an electrical rules checker, and it will check for various settings which you control. For example, if you've got two output pins connected together, it will flag it as an error or a warning depending on what type of level of warning you want or level of error you want. And then we've got a pin swap rule. Now it's easier to show you this graphically than as a table in the terminal attributes window or pin attributes window. And again, with the pins you can add your own attributes as well if you want to. So if you had delays or something that you wanted to assign, then you could put them in there. Right, so let's have a look at this pin swapping rule. If we go up to the terminals command and choose set pin swap rule, you can see on this component now the terminals have been replaced by coloured circles and they're both set to red, and we've got some pin swap rule colours up here. Now any terminals that have got the same colour are electrically equivalent to one another, so when you start placing your parts on the artwork, you're allowed to swap the connections between their pins. It doesn't matter what colour you assign, as long as all the equivalent ones are set the same. And if you wanted to change them, you just choose a colour and then choose your pin. So we've not altered anything apart from the colour, basically. What you wouldn't do is have one red and one green, because that would mean they weren't equivalent to one another. When we assign the pin numbers to the components, we've already used pins 1 and 2, and it will automatically expect to use pin 3 as the next number. You can use alphanumeric numbers if you want to, so if you had a connector and the pins were labelled A1, A2, you can just type it in, or if you had a anode and cathode and you wanted to just use A and C or K, whatever, you can do that. I always recommend when you're creating your own symbols or modifying existing ones to use this terminals check command. That will tell you whether you've got any pins that have been unallocated or you've used duplicate pin numbers. It's not easy to do, but it can occur. So always run that terminals check, and we've got 2 normal pins and no power pins, and that's exactly what I'd expect to see for a resistor. So that component looks okay. Right, so let's have a look at another type of resistor. If we look at one of the surface mount resistors, this one's slightly different in that they didn't put any stalks on the symbol when it was made, but that's irrelevant. And the only other difference is that rather than putting the 100k value in there, they've just put XXX. So when you place this one on the circuit diagram, you're going to have to edit the value if you want something sensible to appear on there. So as I say, I tend to put the most common value in, and then you won't have to change all of them. So those are just discrete resistors. So we'll scroll down and have a look at some other resistors. And down at towards the end of the list, we've got some resistor networks. So we'll have a look at this one. The only difference you can see when you look at it really is the fact that it's called RN as opposed to R, so that you know it's a resistor network. Now if we look at the attributes on this symbol, you'll see the number of equivalent symbols within the part is set to 4 this time. So there are 4 of these resistors in the one package, and the outline that's called up is a single inline 8-pin package. So if we have a look up at the icon bar across the top, you can see we've got this setting here, which is showing us that we're looking at instance 1 of 4 within this part. And using this slider bar here, you can either slide it across or use the arrows. And this allows you to look at each gate within the package. So we're looking at the first one now. Now we're looking at the second. We're using the pins 3 and 4. And then the next one, 5 and 6, 7 and 8. And then if we have a look at the resistor network where the pins have one pin is common, and you can see this one is shown as one package with one common pin and then the other resistor pins, and up the top here there's only one instance. So if we have a look at the equivalent pins on this one, you'll see that all of the resistor pins have been set as equivalent to one another, because any of those resistors can be swapped on the artwork without affecting the electrical sense of the design. If I go back to the resistor network that had the 4 resistors within it, if we go back to the attributes, we've got a symbol swap rule. And this relates to the whole symbol, so it's the complete resistor, and we can set it that we don't allow any swapping. We can swap globally or swap locally. So what this means is that on the artwork, if you've got 4 resistors in that package and you want to swap one for another, you will be allowed to, depending on the setting here. So if you just want the resistors to swap locally within the package, so any one of the 4 can be swapped with any of the other 4, you say swap locally. If you want to allow it to swap with any other of those resistors in similar packages, you swap globally. So in this instance, I'd be quite happy to allow global swapping to take place. Right, so the next thing to have a look at is a slightly different type of component. So we'll go back up and have a look at some parts that you should be fairly familiar with, the 7400 series, and we'll look at a 7400. Now, if we look at the properties, we can see the part prefix is IC. It's used in a dual inline 14 pin package, and the value is 7400. We've got a symbol swap rule set, and we've got some power pins this time. So how are all of those set? So we've opened it up, and if we go up to the symbol attributes, again, number of equivalent symbols within the part is set to 4. The rest of it you're fairly familiar with. The thing I wanted to show you for this particular part is the part power pins window. We've got 2 power pins defined, pins 7 and 14, and they're connected, or will be connected, to GND and VCC when this part is used on the circuit diagram. That's how implied power pins are defined. So when you use this part on the circuit diagram, you can place as many of these gates down as you like, and they'll be assigned to a package, so 4 into each package. Again, up here we've got the instance where you just click through and you see the different pin numbers for each symbol. This is symbol 2 or instance 2 with pins 4, 5 and 6, instance 3 and 4. So no power pins shown on this package at all. But when you use it, as I say, it will automatically join the power pins to the appropriate rails, and you define that in the attributes power pins table. And when you want to add, if you had an extra pin, you just hit the new button, you tell it what the pin number is. I'll put 16 in this instance because I'm not going to use it, and V+. And then when you OK it, it appears in the window. Now that is nonsense for this particular part, so I'm going to delete it. And bear in mind, I'm working in the master schematic library at the moment, so any changes I make will be, if I choose to save them, will be available for everyone else. So you don't really want to be editing parts in the master library. You ought to be doing it within your local job, and then once you know they're correct, then copy them up to the master library. So that's everything for the symbol attributes on this particular part. That is a very brief overview of the schematic part editor for normal parts. Now you've also got other parts where the elements within the part are not the same. For example, if you take a relay, it's got a contact and a coil. Now those are made up using what we call split parts, and I'll do a separate video to explain those. I think that's given you a quick overview of the schematic part editor. There will be a separate video that will take you through step by step creating a part. There is also a worked example in the Getting Started guide, and it's all printed out, and you can follow that through at your own pace as well if you want to. Okay, so this is Hazel from C-Trax signing off, and I hope you've found this video useful. Goodbye.